All right, let's take a look at this second example. And what we have here is a 2 kilonewton per meter distributed load somewhere in the middle between these two supports, a 5 kilonewton meter moment on the end. I went ahead and did the reactions, the statics for the reactions for you, so that first step is done. I got 3.375 on that left-hand side and that 4.625 kilonewtons at that middle support. And we're trying to find the equation for the elastic curve. So like I said last time, what I would do is I would start by developing my singularity function or my discontinuity function, and I would start with the moment. So the moment as a function of x is equal to, and then the first one I have over here is this point load of 3.375. So I go to my table, I see it's case number 2 at the point load, and I'm doing the moment, so I have p x minus a to the first. So what I would say is I have 3.375 x minus, well, a is 0, so I would just leave it as x, and we said that was to the first power. The next thing I have is this distributed load. It is pointing down, and so I go, this is case 3, it's pointing down, so I'm going to have negative. Once again, I'm talking about this moment function over here, so I have the distributed load over 2 times x minus a squared. So what I have is minus 2 over 2, 1, but I'll leave it as 2 over 2 for now, x minus a, and this is occurring at 2 meters over, so I have x minus 2, and this is to the second power. Now that turned it on, and then once again we need to turn it back off. So I'm going to say plus 2 over 2 x minus 6, and that is also to that second power. Then I have that other point load, so it's going to look like the first one, 4.625 x minus, and this is occurring at what, 4, 5, 6, 7, 8, so a is 8, and this will be to the first power. And then that 5 kilonewton meter, I'm not even going to put on there because it is in essence irrelevant, right? Then I'm going to integrate. The first integration, don't forget your EI, will be my theta of x, right? So now I'm just taking the integral of this guy. So what I have 3.375 over 2 x squared minus 2 over 6 x minus 2 to the third power plus 2 over 6 x minus 6 squared plus 4.625 over 2 x minus 8 squared. Brackets looking a little bit funky. Now remember, when I'm doing that first integration, I get my first constant of integration, C1. Integrate again for my EI v of x. And now we have 3.375 over, was it 6 x squared minus 2 over 24. It'd be x minus 2 to the fourth plus 2 over 24 x minus 6 to the fourth. Looks like I had a little error in there, didn't I? This is supposed to be cubed. That would have been a Fonz book. I'm sure someone would have caught me on that one. But yeah, just little mistakes will get you every time. Be careful out there, right? And let's see, where am I? And then I have plus 4.625 over 6 x minus 8 cubed plus c1x plus c2. Now I have those equations. I want to use those boundary conditions or initial conditions to solve for those constants of integration. So what do I know? Well, once again, I don't know anything about the slope on this one, but I do know that the deflection is 0 at the supports. So at x equals 0, I know my deflection must be equal to 0. It's usually an easy one. Plugging in my zeros, I have 0 squared times that business. This first term is 0 minus, and then the 0 minus 2, well, that one, it would be negative, so that one's not on. So this is 0. Plus, same idea with this guy, 0. Same idea with that guy, plus 0. And then I have plus C1x, so that's 0 plus C2. And I have the whole thing equal to 0. So from that, I end up with C2 is equal to 0. For my second boundary condition, I know at x equals, what is that, 8, my deflection will be equal to 0. So just plugging in those 8s, I have 3.375 over 6 times 8 squared. Another integration error. This should be cubed. Man, I'm glad I'm not in class right now. It'd be costing me a bundle. Minus 2 over 24. And then I have what? 8 minus 2 is 6 to the 4th. Plus 2 over 24. 8 minus 6 is 2 to the 4th. Plus 4.625 over 6. But this whole thing is just times 0. So really that whole thing is 0. And then I have C1x plus C1x is 8. And C2 we already said is 0. And that whole thing has to equal 0. So the only unknown there is C1. If I did my math right, I got C1 to be 22.67. So then the last step, putting it into my form, moving that EI to the other side to make it look a little cleaner. And I end up, after I put it all in there, with something like that. Now, a good question on an exam would be to give you that and say, what is the deflection at x equals, I don't know, maybe like 2 meters or something like that. Or if I said, what is the maximum deflection? You could take the derivative of that equation and set it equal to 0. I'd probably have to tell you which one of these are on or off. So it would have to say something like, assuming that the maximum deflection is between 0 and 8, right? So usually the problems might say something like that. But more than likely, just knowing this process, you should be just fine. Let me know if you have any questions and comments, and I'll talk to you all later. Thanks.